The universe runs on rules. Rules that govern everything, from the motion of planets, to the birth of stars, to the very fabric of space and time itself. And for the most part, those rules work perfectly. But not always. Because scattered across the cosmos are objects that shouldn't exist. Not according to our equations, not according to our understanding, not according to physics itself. And yet, they're out there. We're counting down 10 cosmic objects that don't just challenge what we know. They break it. Number 10. WASP 17b, the backwards planet. Imagine building a solar system. You start with a spinning disk of gas and dust, everything forming in the same direction, like water swirling down a drain. That's how every planet we've ever observed is supposed to behave. Except this one, WASP 17b, orbits its star backwards, not just slightly off, completely reversed. Like a car driving the wrong way down a motorway at full speed. According to every model of planetary formation, this shouldn't happen. The leading theory? Something catastrophic flipped it. A gravitational collision so violent, it rewrote the planet's entire orbit. But here's the problem. We've never seen anything powerful enough to do that, so we're left with a planet that simply refuses to follow the rules. And this is just the beginning. Number 9. Boyajian's star, the star that flickers. Stars don't just randomly dim. When something passes in front of them, a planet, for example, the dip in brightness is small, predictable, repeatable. But Boyajian's star does something else entirely. It drops in brightness by up to 22%. That's not a planet. That's something enormous. And worse, it happens with no clear pattern. Scientists tested everything. Dust clouds, comets, instrument errors, nothing fits. Every explanation breaks down, which leaves us with an uncomfortable truth. We're observing something we don't understand. And when the universe stops making sense, that's when things get interesting. Number 8. The cold spot, the hole in the universe. When we look at the oldest light in the universe, the afterglow of the Big Bang, we expect it to be almost perfectly uniform. And it is. Except for one place. CMB cold spot, a region of space nearly 2 billion light-years wide, that is significantly colder than everything around it. It's not just a fluctuation. It's too large, too deep, too wrong. One theory suggests it's a supervoid, a vast region with almost no galaxies. But even that doesn't fully explain it. Another theory is far stranger, that this is a scar, left behind by a collision with another universe, a place where our reality brushed against something else. For the first time in this list, we're forced to consider something unsettling. Maybe our universe isn't alone. Number 7. Tarn 618, the impossible black hole. Black holes grow over time, slowly, by consuming matter, merging with others, evolving across billions of years. But Tarn 618 didn't get the memo. This black hole has a mass of 66 billion suns. To put that into perspective, if it sat at the center of our solar system, its event horizon would swallow every planet. Even at the maximum theoretical growth rate, there hasn't been enough time since the Big Bang for something this large to exist. The maths say, impossible. The telescope says, there it is. And when observation contradicts theory, it's not the universe that's wrong, it's us. Number 6. Fast radio bursts, signals from nowhere. In 2007, astronomers detected something strange, a burst of radio waves, lasting just milliseconds. But in that fraction of a second, it released more energy than our sun produces in days. These are called fast radio bursts, and they come from billions of light years away. Some happen once, others repeat. One source pulses every 16 days. Think about that. If you detected a signal with a precise repeating pattern, would you call it random, or would you call it a message? We don't know what causes them. Magnetars? Maybe. Exotic physics? Possibly. Something else? We can't rule it out. And that uncertainty is where the mystery lives. Number 5. The Great Wall, too big to exist. The universe has a structure. Galaxies cluster together, forming filaments, walls, and voids. But there's a limit. There has to be. Otherwise, there wouldn't have been enough time for structures to form. And yet, Hercules Corona Borealis. Great Wall spans over 10 billion light-years. That's roughly 1/14 of the observable universe. It's so large, it breaks the principle of cosmic uniformity. In simple terms, the universe shouldn't be able to build something this big. It's like finding a mountain larger than the Earth itself. At this point, we're no longer bending the rules. We're snapping them. Number 4. SDSSJ 03131806, born too early. Let's rewind to the beginning, just 670 million years after the Big Bang. The universe is young, chaotic, still forming. There hasn't been enough time for large structures to develop. And yet, SDSSJ 03131806 already contains a black hole 1.6 billion times the mass of the Sun. Even if it started growing immediately and consumed matter at the fastest rate physically possible, it still couldn't reach that size in time. This object didn't just break the rules, it ignored them completely. Which forces a deeper question. Are our models of black hole growth wrong? Or is something else happening in the early universe we don't yet understand? Number 3. The Methuselah star, older than time. This one is personal, because it's close, just 190 light-years away. HD 140283, nicknamed the Methuselah star, was once measured to be 14.5 billion years old. There's just one problem. The universe itself is only 13.8 billion years old. A star cannot be older than the universe it exists in. That's like finding a tree older than the forest it grew in. Now, later measurements reduce the uncertainty. But the margin is razor thin, uncomfortably thin. So we're left with a choice. Either our measurements are wrong, or our understanding of the universe's age is incomplete. And neither option is comforting. Number 2. The Great Attractor. Something is pulling us. Right now, you are moving through space at over 2 million kilometers per hour, not orbiting the Sun, not orbiting the galaxy, but being pulled towards something massive, something we cannot see. Great Attractor lies hidden behind the dense dust of the Milky Way, in a region we call the zone of avoidance. We only know it exists because of what it's doing to us. It's pulling entire galaxies, thousands of them, toward a single point. We don't know what it is. We can't observe it directly, and we cannot stop moving toward it. Imagine being on a ship, drifting toward something in the fog. You can't see it, you can't steer away, but you know, it's there. Number 1. The Hubble tension. Reality is cracking. This is the most dangerous one, because it's not just an object, it's a problem, a crack in the foundation of physics. The expansion rate of the universe, known as the Hubble constant, can be measured in 2 ways. Looking at the early universe and observing galaxies today, both methods are precise, both are well tested, and both give different answers. This is known as Hubble tension, and it shouldn't exist, because both answers cannot be correct, which means one of 2 things is true. Either our understanding of the universe is incomplete, or something fundamental, like dark energy, gravity, or even time itself, is wrong. Not slightly wrong, fundamentally wrong. This isn't just a mystery. It's the universe, telling us we're missing something big. The deeper we look into the cosmos, the more we realize we don't fully understand it. Not even close. Because for every rule we discover, the universe presents an exception. And for every answer we find, it asks a deeper question. Maybe that's the point. Not that the universe is broken, but that we are still learning how to read it. If you want to explore more mysteries like this, the kind that challenge everything we think we know, then subscribe to the Space Vault. Because out there, the universe is still hiding its biggest secrets.